Here, we want to integrate this integral 1 over x minus 2 and multiply by x minus 5 dx. However, we want to integrate this integral without using the table of integration. So you may wonder in some cases that how the table of integration is constructed. One of the methods that they use is using partial fractions. So to solve this integral here, we're going to apply the partial fractions. And then we're going to use this note to help us to solve this using partial fractions. So this is in case if we have a rational function p of x over q of x of the degree of p of x as larger than or equal to q of x, then we use long division. This case does not apply in here. So we're going to move to the next step here of a q of x is the product of distinct two linear function, which is the case in here. We have two distinct linear functions. Use partial fractions of the form of a over x minus c. Let's do that. So let's take the integrand first, which is 1 over x minus 2 and then x minus 5. That's going to be equal to a and then the first, which is x minus 2, and then plus b and the second, which is x minus 5. So what I did here, I break this fraction into two fractions. The first fraction in here with a, and then the second fraction in here with b. Now the idea of partial fraction is this fraction here going to be equal to this fraction. So in the end, we're going to try to integrate this one. However, first we want to find what is a and then what is b. So let's solve for a and b. First, I'm going to multiply both sides by the dominator in here, which is x minus 2 and then x minus 5. So the left side going to be just equal to 1, and then on the right side it's going to be a and then x minus 2, x minus 5, and over its dominator, which is x minus 2, and then plus b, and then multiply by x minus 2, multiply by x minus 5, over its dominator, which is x minus 5. Now, let's simplify. Notice that this term will go with this term, and then this term will go with this term. So that can be written as 1 equal to a, and then multiply by x minus 5, and then plus b, multiply by x minus 2. So again, we want to solve for a and b. To solve for a, I'm going to equal x to equal to 2. So now we have 1 equal to a, and then 2 minus 5, and then plus b, and then 2 minus 2. Notice that this term will be 0 since 2 minus 2 is 0. So now we have 1 and then equal, and then 2 minus 5 is minus 3a. We solved a, so it's going to be minus 1 over 3. Now to solve for b, I'm going to equal x to 5. So we're going to have 1 equal to a, then 5 minus 5, and then plus b, 5 minus 2. Notice that this term will go in here to 0, since 5 minus 5 is just 0, and we are left with 1 equal to, and then 5 minus 2 is just 3b. Therefore, b gonna be equal to 1/3. Now we already found the value of a and b, so let's go back to here and plug that in here. So again, 1 over x minus 2 multiplied by x minus 5 gonna be equal to a, which is 1 over 3, and then the fraction is x minus 2, and then b, which is 1 over 3, and then multiply by the fraction x minus 5. Now the next step is to integrate these. So again, we have the integral of x minus 2, x minus 5 dx. This is what's given. It's going to be equal to the integral of minus 1, 3, and then 1 over x minus 2, plus 1 over 3, and then multiply by 1 over x minus 5 dx. Now this is going to be equal to minus 1 over 3. I pulled that out of the integral, and then we have the integral of this term, which is 1 over x minus 2, and then we have dx, and then plus the integral of this side. But first, I'm going to pull that out of the integral. It's going to be 1 over 3, and then the integral of 1 over x minus 5 dx. Now the last step is to find what's the antiderivative of these functions in here. I'm going to call this number 1, and then I'm going to call this number 2. So let's find first number 1, which is the integral of 1 over x minus 2 dx. Here, to solve this integral, we're going to use substitution. So u going to be equal to x minus 2, and then du going to be equal to dx. Now, this integral going to be equal to 1, and then the denominator going to be equal to u, and then dx just du. This is going to be equal to natural log of the absolute value of u. Now let's back substitute the function of u. It's going to be equal to the natural log of the absolute value of x minus 2. That's for number 1. Now let's find number 2. We have the integral of 1 over x minus 5 dx. I'm also have to apply u substitution here, but I don't want to confuse u with this u. So I'm going to call this w substitution. So w going to be equal to x minus 5. Therefore, dw going to be equal to dx. Now I'm ready to substitute. This integral going to be equal to 1 over, and then the denominator is just w, and then dx is dw. This integral going to be equal to natural log of the absolute value of u. Now let's back substitute the function of u. It's going to be natural log of the absolute value of x minus 5. Now let's put the antiderivative back into here. This is going to be equal to minus 1, 3, and the antiderivative of number 1, which is natural log of the absolute value of x minus 2, and plus that constant, which is 1 over 3, and then y antiderivative of number 2, which is natural log of x minus 5, and then we don't forget the constant plus c. And that should be the antiderivative of the integral. Note this integral also can be solved using the table of integration.